Tiger will carry you to your bed, bro.
Tiger is already dead. Tiger is talking with her, with his,
But we have started the stream.
All right,
Sensitive
let's go.
topics. Let's refrain from sensitive
Yes.
topics.
Let me just call Tiger with one thing, and then Tiger comes running.
What? With what?
You know what time it is?
Hmm. All right, we are
Uh,
live.
yes. Okay. So rendering with USD. So this
Wait, bro.
document.
Wait. You're fucking starting with anything.
Oh, I think
Uh,
Tiger is coming out. Forbidden.
the tiger is out.
I'm hearing some footsteps. So let's see. Oh yeah, I'm hearing some footsteps. I think the tiger is awake.
So, do you want to show tiger on stream?
I don't know, but if tiger comes out, then I can show, right? I don't know if he's gonna come out or not.
Okay. So, this is day 72. We are trying to. Okay, so also I gave my result to Claude and I gave it the potential questions that we jotted down the other day from the exam.
Mm-hmm.
And
And create a photo.
no, it did not create, it just pointed out like what to focus on. Like, obviously, we know that, but it's also focusing on the kind of like I was trying to make it understand the type of pattern that we are being tested on in
Mm-hmm.
the exam.
All
So I
right.
was, um, so yeah, it came up with this kind of, you know, first an exam question answer key,
I
and
see.
then it also created some sort of retake plan.md 14-day plan.
Mm-hmm.
Priority ranked by, I don't know where that is. Let me take a look. Retake plan, yes. I've not looked at it yet. So,
Mm-hmm.
yeah, so this should be our, priority data exchange, data modeling, and pipeline development, which was the least that I
Mm-hmm.
scored on. And this was decent. um, so, yeah, composition and everything, composition, customizing, USD, and content aggregation are good. Like the base is strong. Debugging and troubleshooting is decent, not too best, but it's decent. Visualization is weak, but we can cover it.
Mm-hmm.
The main thing that we have been working on is data exchange right now and data modeling. So
Mm-hmm.
yeah, um, composition. Yeah. So principles: drill the recalled questions first. It's grounded exam question key. Okay, so it's saying that do the exam question answer key MD. So this is the one that it's asking us to do first.
Mm-hmm.
We can get to it later.
Mm-hmm.
And then data exchange sources in data exchange.md focus on USD USDC when each file format plugin. This is what we have done, I think. Data modeling, pipeline development, and all that stuff. Okay. Retake gate. All must be true before rebooking.
Retake what?
So this is like the like before we rebook the exam. This is what we should have.
Mm-hmm.
So we should be able to explain every item in the exam question answer key.md that does created each of the three critical domains. A practice set scored 90% plus. Then visualization plus debugging practice set should be greater than 90%, and two full 70 question weighted mocks should be scoring 90% plus overall with no single domain below 90%. So that is a good plan. And then
Mm-hmm. We
build
move
targeted
from
data modeling. So this is something we can start working on once we finish this. We have completed what in data exchange. We are done with the technical references. I think we have to do. We did maximizing USD performance, right?
yeah.
And we also did encoding
No,
stage
no,
up
no. We
access.
completed encoding stage of access. We completed the encoding stage of access.
Yeah,
We need to
before
work on
that we did not do this.
what. Dude, we did that as well. We did that as well.
Okay, so do you remember package assets with payload? Oh yeah, we did this. Correct, correct. Yes, we did this.
So we have to focus on creating new schema process with USD Gen schema.
Mm-hmm. Okay, let's start from. Hmm. Oh yes, we did encoding stage up access. I think we did not finish it though.
We did finish it. That's how we ended the stream after finishing the encoding stage of access.
What is TF token here? User string type. Mm. Okay, so let's just finish this part and then we'll move to creating new schema classes with USD and schema. Um, Correct interpretation, C ups asset. Application knows C is vertical, asset stands upright, and correct interpretation, Z up asset. Application assumes Y is vertical, asset may appear rotated, lying down. Oh, we did have a question over here, right? In the quiz that let me open the notes. I remember the thing. What was that question? We
Regarding?
we were shown two uh, asset files
Mm-hmm.
where their up axis was Z up and Y up respectively, and the layer in which they were called had the up axis set to Y axis.
Mm.
The question asked, how would these assets appear on the stage, on the composed stage? This was one of the questions. Options were something like both are Y up, both are Z up, one is Y. originally y and one originally v. Something like this. Correctly and explain the correct answer and concept. Ha, ha, ha. Okay. So you're saying you only wanna do stream till 12,
Yeah.
but it's already 12:16, bro. What are you talking about?
Like till 1 for you, 12 for me.
Till 1 for you and 12 for me.
1 for you, 1 for you, 12 for me.
So till 1 o'clock for you, which is gonna be like for till 2 for me.
Brother, I will just stop at whenever I like. I will say adios, amigos, then you can carry on. That would be my response.
Okay. We were doing this. Yes. If up axis is wrong, the scene may appear sideways or incorrectly oriented on other application. So correct interpretation is Z up asset. Application knows Z is vertical. Asset stands upright. Incorrect interpretation. Z up asset. Application assumes Y is vertical. Asset may appear rotated lying down. So this is a wrong interpretation. Okay. Important gotcha. It does not rotate geometry. This is the most important mental model creation. Correction. Sorry. USC geom dot set a stage up axis. Okay, so set stage up axis stage USC geom dot tokens dot z does not transform your points from y to z up, or it only authors metadata up axis equal to z. Okay, it only authors metadata up axis does not transform your points from y up to z up. Okay, wrong mental model that rotates my whole stage node. Correct. So set stage up axis labels the stage coordinates convention. So it only updates the metadata. It does not does like any transformation. If you actually need to
Mm-hmm.
convert geometry from y up to z up, you must author transforms or convert data points, convert point data. Suppose your mesh points are this. If you set up axis is z, the points do not change. Before point is equal to same value, after point same value, stage metadata says z up. How to identify it in an exam question? In an exam question, look for a USD asset should declare whether it is y up or z up. Correct concept, stage up axis metadata. Okay, which function sets the stage's vertical axis? USD geom dot set stage up axis. Stage USD geom tokens Y or USD geom tokens Z. Okay, a reference asset uses USD geom set stage up axis. This was encoding stage. Okay, even yes. Okay, set stage up axis. Set stage up axis. Okay. Look for a reference asset uses different units or up axis. Will USD automatically convert it? No. Up axis metadata declares convention. It does not automatically rotate the geometry. This is similar to meters per unit. Metadata helps tool interpret the scene, but USD composition does not automatically rescale or reorient reference data just because metadata differs. Yeah, one question was also in the quiz. Actual quiz was which of the uh, metrics or metadata automatically rescales in a different stage, I guess, or in a different layer.
It's time code, right? Time code
Only time code and time samples are the ones that get
and
rescaled
frames
automatically. Other
and
than that,
frames.
yeah, the answer was meters per unit and kilograms per unit, and what was the other one? I think
I think time
axis.
code, yeah, or
No,
access.
time code
Kind
and
of
time
it.
sample do scale automatically.
Yes.
Yeah, okay. Metadata helps tools interpret the scene, but USD composition does not automatically rescale or reorient reference data just because metadata differs. Common gotchas, only Y and Z are valid stage up axes. You cannot set arbitrary axes like X up. Okay, the functions expect USD geom tokens Y or USD geom token Z. Gotcha 2, up axis is stage metadata, not a prim transform. This is not the same as double three X form OP rotate XYZ. The up axis is authored in the layered metadata area. So USDA 1.0 up axis is Z, not inside a prim as a transform OP. Fallback is not the same as authored metadata. If the stage has no authored up axis, get stage up axis can still return a value because USD uses a fallback. Because USD uses the fallback. Okay, if the stage has no authored up axis, get stage up axis can still return a value because USD uses the fallback. I see. Up axis is stage moderator, not a prim transform. This is not the same as double X form OP. Rotate XYZ. Up axis is authored in the layer metadata area. Up axis is stage moderator, not a prim transform. This is not the same. Double three X form OP rotate XYZ. Up axis is authored in the layer metadata area. Yes, not inside a prim as a transform operation. Fallback is not the same as the authored metadata. So if the stage has no authored up axis, get stage up axis. Get stage up axis, fetch and return stages up axis. Can still return a value. USD uses the fallback. So return value exists does not mean the layer explicitly authored up axis. Okay. Up axis mismatch can cause visual confusion. A scene may be technically valid but visually wrong if imported exported with the wrong convention. For data exchange, always check up axis meters per unit, default prim, asset paths, and material bindings. Okay. So USD Geom set stage up axis reads whether a stage is Y up or Z up. USD Geom stage up axis set stage up axis authors that metadata using USD Geom tokens is Y or USD Geom token Z. USD Geom get fallback axis returns the site level default when the stage has no explicit up axis. This metadata helps tools interpret orientation but does not rotate the geometry automatically. Up axis labels the world, it does not turn the world. Okay. The correct interpretation is composed stage has one declared up axis, Y up, because the calling slash root layer sets the stage up axis, but USD does not automatically rotate the referenced assets. So the assets authored as Z up keeps its Z up numeric orientation. And the bro, look at this. I was telling you, it does not rotate it automatically. For
What
that
does not rotate
question,
it automatically?
that we had,
Has one declared up axis, y up because wait, the correct interpretation is the compose stage up stage has one declared up axis, y up because the calling root layer set stage up axis to y, but does not automatically rotate reference. No, when did I say it will rotate automatically? I said we have to perform a plus 90-degree rotation
no,
if we want to.
I'm saying the question that we had was in one layer we in one prim the up axis was defined as y, and in another prim the up axis was defined as z, and those two
Mhm.
prims were called into the root layer where the root layer had the up axis set as y, and the options we were
But
asked was how was
but
prim 1 and how was prim 2 gonna appear on the root on the stage
uh,
when composition occurs.
so even if the default axis is set to even
Why?
if the default axis is set to y, no, so because one of the thing I do remember from that question was the default axis was set to z.
No, the
You
default
remember the
axis was
default
set.
axis?
No, 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 no. The default axis was set to y, and then we were
No,
asked.
no, 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 no. No, no, no. I'm talking about the whole prim. So like this whole layer. So for the whole layer, initially in the initial parenthesis brackets where we define default, right? So over there, the default up axis was set to z. That's for sure. And
No,
in the
it was
cone
for
individual.
y, bro. It was for y. I remember it correctly. And then
Okay,
one
okay, okay.
option
Go
was
ahead.
y, and one option was one prim had it set to y, and another one had it set to z. And then they called both of those prims in the root layer via some reference or something. I don't remember how. And then they
Hmm.
asked us how would these two prims appear on the compose stage. So the
Hmm.
right answer would have been whatever the up axis was defined for those prims in their root file in their particular layers is how
Okay,
they
so
are
the
gonna
correct
be
one
appearing.
but that up axis y because column root layer set the stage up axis to y, but does not auto rotate reference asset. So
Okay, read
okay,
this.
so you have two asset file. One asset file has up axis z and the other has y. Both assets represent the root user whose root up okay has y. When stage is composed, how are the reference oriented? Does know the composed stage up axis metadata is y up, but USD does not automatically rotate or convert the reference asset geometry. The Y up asset remains Y oriented and the Z up asset remains Z oriented
Yeah,
unless you.
I think I messed it up. Like this is was one of
Oh,
the
okay,
question
okay.
that I got wrong.
Hmm.
Definitely. Do you get it now?
Yeah, bro, I get it. I get it. It clears a lot of concepts.
Yeah, see, I think this was exactly the question. It says,
Okay, let's look at the assets. Oh yeah, yeah. This was exactly the question. Yeah, I do
yeah,
remember. Okay.
so up axis is y, up axis is z. And then when composed into root stage, geometry still authored with y as vertical, z as vertical. So USD does not automatically convert z up asset to auto rotate into y. Yes, similar to meters per unit. Bruh. Yeah, I think this is something we should have learned. See, it's also saying the correct answer is not. Both becomes y.
Y stands up related to Y versus years. Okay. So root is Y up when referring composing graph. The value is root Y up stage Y stands later. Oh, makes sense.
Yeah, let me check the weather tomorrow, bro. It's fucking hot.
Dude, you know it's raining like crazy today, like in the night.
Yeah, here as well. Or tomorrow it's still decent, but I need to wake up early tomorrow to go to the gym. It's gonna be really hot afterwards.
Hmm.
Hell no. Okay. So this was one of the main things that we got cleared.
So I still have a doubt. So it says
Ask.
Z up asset. still has its vertical direction along z. So when we are bringing a
Hmm.
z up asset into a y up stage, how will
Uh,
it look like?
so you
Like
see
will
over
it
here,
be?
the correct practical answer is the original Z up asset appears Z up unless corrected.
So that means it will come inverse, like flipped basically, right?
Oh yes, Z oriented. Like wherever Z
Yeah,
is,
okay, okay, because
it will have the orientation towards Z. Oh,
hmm.
hmm. Hello, Shaurya. Who is this guy?
We got someone at stream.
Yeah, somebody in the chat. Hi. Hello.
Hey bro, SH487219, brother from another mother.
I think it is Shubham. Shubham Vyas,
Oh,
I
it's
guess.
uh,
Yeah, I'm
Vyas.
guessing. I'm just taking a guess because he connected with me on LinkedIn and on Twitter.
I see.
Yeah. Okay. So this was the important nuance. There are two different questions that sounds familiar. What is composed stages up axis metadata y up? Are referenced assets automatically reoriented to the match the root stage? No. How will the assets visually appear if no correction transform is added? Y up asset remains Y up, Z up asset remains Z up, misoriented relative to the Y up stage. How to fix it in a pipeline? If you know an incoming asset is Z up and stage is Y up, you must explicitly convert it. One common correction is to add rotation to the referencing prim. Conceptual example: def x form asset Z up, asset B Z up. So prepend reference is this. Okay. Oh, so this is how you perform the rotation. If you know that it is incoming is Z, so you basically perform some kind of rotation on it by this attribute x form op rotate x and perform a minus. Oh, I think we did this as well.
So you remember, like, it's always going to be right-handed,
Yeah.
and you have to perform a rotation. So it depends upon how is the axis set up. So if the axis is set up to y, right,
Mm-hmm.
then you
Mm-hmm.
have to perform a plus 90-degree rotation to make
Mm-hmm.
the z axis up, like upside. So like
Mm-hmm.
your hand is like this,
Mm-hmm.
and your x axis is pointed towards your right. So and this is going to be your y, and down is going to be z. So you have to rotate it like this to bring the z up. Otherwise, z would be pointed down.
Mm-hmm. Okay. So common gotchas are stage metadata is not a transform, reference layer metadata does not override root stage up axis. Okay, when y up root stage references one y up asset and one z up asset, the composed stages up axis is y up. However, USD does not automatically rotate or convert referenced assets. So the y up assets keep its y up orientation and z up assets keeps its z up orientation unless an explicit corrective transform or conversion is applied. Up axis labels the stage it does not reorient referenced assets. Gotcha. All right. So encoding stage up axis, is there anything else left over here? We did these three functions. Detailed description, okay. Even if all USD geom camera objects in a scene are encoded with a transformation that assumes y-axis is up, that cannot always imply that geometry contained in the scene was modeled with y-axis pointing up, since some modeling applications assume z is up and other allow you to configure whether y or z is up. Okay. Rather than impose one axis on the other on all other USD geom scenes, which would require either transposing point coordinates into and out of some applications or making assumptions about where a minus 90-degree rotation has been applied and effectively mysteriously swapping the roles of y and z coordinates. We allow each stage to carry its own, in its root layer a declaration of the up axis for all the geometry contained in the stage and require application to consult if they wish to create new cameras to view the scene in its intended orientation. Okay, we provide free okay, note that because you can make only a stage level declaration of up axis, it must hold true for all reference geometry and assets. A consensus set environment construction tool could examine the up axis of reference asset. Okay, so this is important, bro.
Mm-hmm.
A consensus set environment construction tool could examine the up axis of the referenced assets as they are being referenced and apply a corrective rotation on the referencing prim as it is being added to the scene when the referenced up axis differs from the sets. So this is exactly what
Mm-hmm.
we needed to do over here to make it, be aligned with the y up axis.
Mm-hmm.
We provide free functions for setting USD geom set stage up axis, retrieving USD geom get stage up access and after and declaring site level fallback. Okay, and that can be configured with a plugin for .json file. See the individual methods for details. Okay, the stage up axis is encoded as stage metadatum up axis whose legal values are y and z, represented with GOSD geom tokens and y and z. Of course, construction correct camera view of a scene depends not only on the up axis but also on the handedness of the coordinate system like OpenGL. The fallback of USD geom gprim get orientation attribute USD geom stipulates a right-handed coordinate system. Okay. Therefore, when viewing a USD stage with a y up axis and the stage's z axis will be pointing out of the screen, and when viewing USD stage with Z up axis, the stage's Y axis will be pointing into the screen. Okay. In a generic installation of USD, the fallback will be Y. This can be changed to Z by adding a plugin for .json while discoverable by USD's plugin and mechanism. Mr. Suvi Ronaldo. Hmm. USD Geom get fallback up axis. All right, so I think we are done with encoding
Mm-hmm.
stage up axis. We can go to creating new schema classes with USD Gen schema. Creating new schema classes with USD Gen schema. All right, let's start. USD provides a code generator script, USD Gen schema, for creating new schemas. The script is driven by USD layer, typically named schema.usda, and generates the necessary C++ class and supporting Python code for all schema classes defined in it. The USD layer must meet the following prerequisites in order for generated code to compile and work with USD code successfully. Must specify the library name as the layer metadata. Schema type names must be unique across all libraries. Attribute name and tokens should be camel cased. What?
Camel
Must
cased valid C slash
no no no
Python
no. I'm
identifier.
looking at this. Wait. Must specify the library name as layer metadata. Okay. Schema type name must be unique across all libraries. Type names like okay across all libraries. Hmm. So
Must be unique,
like
like there should not be duplicate type names that will
I know
exist.
that, bro. I know that. I'm asking. So like if for example there is a mesh type that we already know.
Hmm. Hmm.
So across all libraries, you mean what all libraries? Which all libraries? All schema libraries?
Yes, all the schema libraries that uses type name, like that are concrete class schema types.
Hmm.
Like APIs would have, I think, custom APIs can have same names, but if you're defining a specific type name, then it should be unique always.
Hmm.
And like you remember, like if you define in Python, if you define a same variable name that is already defined inside the class, then it will throw an error. So that's what it means.
Ah.
That's what it means. So like if you define a type name that is already defined inside your library, then it might collide with it's gonna create memory gaps. So when the compiler runs, it's gonna look for that variable and it will think that okay, this variable is getting reassigned as something else. So
Mm-hmm.
what should I pick it up as? So that's what your unique type name means.
Mm-hmm. I see. Okay, attribute names and tokens should be camel cased valid C Python identifiers with allowance that colon signifies property name spacing. However, if use literal identifier metadata is provided in the schema.usda. Then when creating public tokens for names, token values, etc., code gen will try to use the tokens as is, substituting underscores where necessary to produce valid identifiers, or any invalid identifier will be updated using tf make valid identifier. Okay, tf make valid identifier, also note that as per established convention, schema tokens, library tokens, relationship names, and property namespace prefix tokens follow the use literal identifier pattern. Relationship names and property namespace prefix tokens use literal identifier patterns. USD property common interface for attributes and relationships, and namespace properties in code generation for more information. Okay, we are not going to see that. USD schema.usda must exist in layer stack, not necessarily as a direct sublayer. Okay. If the name's default values and token values are not valid C Python identifiers, then during schema gen, we try to update these such that if the first element of the token is a digit and underscore is prefixed before running it through TF make valid identifier, all invalid tokens are updated to replace any illegal elements with an underscore. Do not do note that since all special characters are replaced with an underscore token, like foo bar and foo dollar bar, it will result in the same identifier. Okay. Yes, we already know this. That TF make identifier will convert all the illegal characters or special characters and replace it with
Underscore.
underscore. Yes. Hence, violating the one-to-one mapping of token identifier mentioned in namespace properties in code generation below. Okay, is a versus API schema. Schema classes can be classified into two types. We already know this. I'm not going to read this again. Applied, non-applied is a schema. I know this, all this shit. Oh, that's it. What? Built-in applied API schemas has API. Yes, we already know schema defined built-in APIs. Mm-mm. Let's see what ChatGPT has. Property conflict composition, API schema, strength ordering. Uh, oh, so you can use a pre-existing API to create your own API schema. I see. Hmm. Okay, let's see this. A USD schema is formal definition of what a prim is or what extra behavior properties it supports. So typed as a schema is a schema, applied API schema, and not applied blah blah. When you create a custom schema, you're telling this prim or type API has built-in attributes, these relationships, these fallback values, and these generated accessor methods. Schema.usda, USD gen schema, C++ schema, Python wrappers, token H, token CPP, plugin info.json, generated schema.usda. The official doc says USD gen schema is driven by USD layer, usually named blah blah blah. Okay, why it matters? You use schema generation when simple custom attributes are not enough. Okay. So, for example, this is a custom attribute def x form robot, custom float, robot joint stiffness. That may be fine for small private data. Okay, but if your studio product real use reusable contracts like robot joint prims always have joint stiffness, damping, limit min, limit max, relationship to parent joint. Then you want a schema. Okay. Schema gives you register type identity, built-in properties, fallback values, generated C++, Python API, runtime schema, registry support, better validation and introspection, plugin discoverability. The core idea schema.usda is not a normal scene content. A schema.usda file is not usually an asset like robot.usda, chair.usda, short.usda, schema definition, file used for code generation. Okay, schema.usd describes USD schema classes, processed schema definitions consumed by USD runtime, plugin for.json, plug metadata. So USD can, okay, discover the schema plugin. The doc says generated schema.usda is processed schema definition consumed at runtime and plugin for.json declares generated schema classes to USD core and can discover plugin prem types. Okay, this doc says generated schema.usda is the processed schema definition consumed at runtime. Okay. I see. Okay, we already know what is a schema and API schema are. Extra properties. Prepend API schema. This premise still a mesh, but it also has a physics mass API behavior properties. The doc says API schemas provide an interface to a prim's quality but do not specify a type name by convention. Their C++ Python class names with end with API. And is a versus API schema, meaning what is a prim? This we already know. Memory distinction, identity attachment. This we already know. Concrete versus non-concrete schema can be authored as a type, def robot, joint, elbow. Abstract base class for other schemas, robot component base. Yes, we already know this. Class robot component base. Inherits type float component mass. This is abstraction. This is abstract slash non-concrete because it has no type name in the class declaration concrete version. Class robot joint inherits robot component base float joint stiffness 0.5. The key part is class robot joint. Okay, that quoted type name makes it concrete instantiable as the typed prim. USD typed robot component base, non-concrete as a schema, robot joint, concrete as a schema, API schema subtypes. API schema split into three important types. We already know this non-applied, non-concrete, robot component base. Mhm. Okay, okay, okay. Non-applied API, helper interface, no third API schemas batch. Single applied once to a prim. So USD model API, USD Geo prim bars API is non-applied. Applied multiple times with instance names, USD collection API, US collections per name. This doc defines non-applied API schemas as cases where recording the API application on the prim is unnecessary, while applied API schemas record slash discover whether the API has been applied to a prim. Single example apply. Okay, so single apply example is def mesh wheel, prepend API schemas, robot mass API. So this is single applied. Robot mass API is applied only once to the schema, once to the wheel. Sorry. Okay, multiple apply is multiple. Okay, prepend API schemas. Collection APIs, colliders, collection APIs, sensors. So it is applied same API schema applied multiple times. So it is okay.
It's a namespace.
Mhm. Visual robot collection APIs, collider, collection colliders include, collection sensors includes. This doc says multiple apply schemas can be applied multiple times on the same prim with different instance names, and the doc say multiple apply schema can be applied multiple times on the same prim with different instance names, and their properties are prefixed with the schema namespace plus the instance name. Manual custom typed schema example. Here is the simplified schema.usds sim style example. Minimal custom typed. Okay, schema. So this is schema.usda over. Okay, so this is a sublayer where schema.usda is a sublayer over global custom data string library name custom class blah blah blah. What the fuck is this? Okay. Hmm. So this is how a new schema would be created when it is defined first in a schema.usda. So overrides global custom data. String library name robot. String library path is period. String library prefix is robot. Okay, class robot joint robot joint. So inherits from typed. Doc a custom typed schema for a robot joint. So that is some metadata. Uniform token joint type is Revolute. So this is the purpose or the joint type is Revolute. Okay, allowed tokens are Revolute, prismatic, and fixed. Okay, the type of robot joint. Okay, float stiffness is one. Dog joint of joint stiffness. Okay, so that this is the fallback for stiffness, fallback for damping, and parent joint is relationship to the parent joint. Okay. So parent joint relationship. So these are the three attributes, and this is the relationship in that schema. Then actual scene could use def robot joint elbow. So elbow can be a robot joint where uniform token joint type is revolute, float stiffness is 2. What USD gen schema generates. When you run USD gen schema in a directory containing schema.usda, it generates schema code. Okay. The doc says the default templates include per class files like schema dot schema class dot h, schema class dot cpp, wrap schema class dot cpp, token files like tokens dot h, and blah blah blah, plus plugin info dot json and api dot h. So conceptually, robot joint schema dot usda definition generate C++ API, robot joint define, get stiffness attribute, create stiffness attribute, get parent joint relationship, create parent joint relationship. Python usage might look like, okay. So this is the Python usage of the schema. So bro, I think if we want to make some open source contribution, we can probably come up with some new schemas to generate and then make them merge in OpenUSD.
Yeah, definitely, bro.
Hmm. That is going to be
That
our
would be a
open
really
source contribution.
great plan.
Hmm. काले है काले और कोड़े है कुर्ते हम भी ना चलते. Hmm. Okay, import your schema module. Global and schema roadies. The global section configures the schema library module. Library name, path, prefix, token prefix, library tokens, skip code generation used for codeless schemas, the doc list, library name as required, and describe library path and library prefix. Bro, now I realize that a lot of questions came from data exchange that we fucked up.
Hmm.
Data exchange is the shit. Data exchange and data modeling and pipeline development. So I personally fucked up in data exchange. Like I scored like 45%, 43%, all that shit.
Hmm.
What was my score out of 70 based on my result? Approximately. वो बोर दे हम भी ना डरते. Alright, bro, it's one. What do you want to do?
Alright, well, yeah, we will just complete this and then I will leave.
Damn, bro, I scored 47 out of 70 exact. Yeah, that's what I thought as well.
Yeah.
Shit! Pancho. I needed to score only 9 more questions right. Only 9. And I would have been a OpenUSD certified motherfucker. What is this, man? But I'm confident. Next time, I get it. I'm gonna get it. For sure. What do you wanna do?
Yeah, well, like, have we completed this?
It's not complete,
We completed.
but no, not complete. We are
Like,
left
how
with.
much? How much is left? Because I was just going through the documentation, like the
It is very long.
what was it is very wrong, right?
Schema,
So
code generation,
how
and
long?
everything. It keeps on going, bro.
Yeah, bro, it keeps on going. But are we gonna go through each and every code line?
Not code, but at least the content. We're not gonna go through all the
Okay.
code, but
So I think we have completed till wait. Hold on. Where till we have we completed it?
we
Yes.
are we are on schema code generation till here.
Wait, what the fuck? Schema
We are doing this right now.
code generation. Wait, let me zoom out a bit because I was looking at the what the fuck. Whoa, yeah. Schema code generation.
We can
Where am I
complete
looking at?
this, bro. We are
Which
reading
part?
it from Chat GPT right now.
Oh
This
no,
part.
yeah, I
So
know we are reading it, but I was trying to take a look into
we are
the
here.
clear
Schema code
document.
generation. Told you 5 times,
Okay,
bro.
schema.
Schema code
Yeah, bro.
generation.
Let me take a look.
What are you looking at?
Dude, I am also on the same documentation, but I'm not able to find that part that you
Bro,
are at.
just command F. Command F schema code
Wait,
generation.
wait. Okay. Schema code
If you are
gen.
not
Oh yeah,
able to
got
find
it.
it, you are on the wrong documentation.
Got it. Yeah, let's complete with this. Yeah, I already went through this. But okay, yeah, let's complete schema code generation,
Let's complete the whole
and
thing,
yeah.
right? If you wanna.
Okay, yeah, let's complete the whole thing. Okay, yeah, let's complete the whole thing. No worries.
All right. So,
Mm-hmm.
so this is how you global schema properties. The global section configures the schema library module. So the
Mm-hmm.
over part is configuring the schema library module. So yeah, we already did this, and then over
Mm-hmm.
here we have already seen that it generates this part.
Yeah.
In addition to the files in schema in the schemata and token related files, the following files are edited by the script generated schema.usda, processed from form of schema definitions that will be consumed at runtime by USD core. Generated schema classes.txt list of generated schema files to be included in the module cmakelist.txt build file. Generated schema.modules.h list of generated schema classes to be included in the modules module.cpp file. Various command line options are available for customizing the code generation process. Run USD gen schema help for more details, creating maintaining new schema module. Okay. So the doc lists library name as required described. Yes, we already know this. Required prerequisites are for generated schema to compile and work correctly. The docs list several prerequisites. The most exam relevant ones are schema.usda must specify library name metadata. Schema type names must be unique across all libraries. Attribute names and tokens should be valid. C++ Python identifiers USD schema.usda must exist in the layer stack. Okay. These are explicitly called out in OpenUSD documentation. Practical meaning. Bad schema names create bad generated APIs. Duplicate type names confuse schema registration. Missing USD/US schema.usda means Base schema definitions are unavailable. Namespace properties. USD schemas are often use namespace properties. So float robot masks like that. USD gen schema turns them into API style accessor names. Float foobar can generate something like get foobar attribute, create foobar attribute. So the doc says USD gen schema supports namespace properties and gives the example that float foobar generates USD my class get foobar attribute and a token whose value is foo bar foo colon bar. Okay, a codeless schemas. A codeless schema registers schema definitions without generating C++ slash Python classes without generating.
Without
Oh.
generating?
Bro, I think we read it somewhere that it generates it.
No, yeah, it generates like if you go down into the documentation, it says otherwise. Go down, go down,
Namespace
more,
properties
more,
in code
more,
generation, USD
more,
gen,
more
blah blah
down,
blah.
go down, go down, yeah, down, down. Yeah, right over here. By default, USD Gen schema generates C++ and Python code.
Hmm. A codeless schema registers schema definition without generating C++ Python classes so by default, providing
No,
appropriate
support
APIs.
schema definitions. Which
Hmm?
we, and here we are talking about the code. So is it some? Is this some? And we are talking about wait.
Okay, wait. Providing appropriate APIs, clients also have
No,
an option of not generating
wait.
any
Read
code
the
by
second
setting.
paragraph. Read the second paragraph. Since codeless schemas do not provide any code.
Do not need to recompile USD to use or update these schemas.
And what does the USD Gen schema says? It generates C++ and Python code. So that's why over here codeless schema registers schema definition without generating C++ Python classes. And because of that reason, schemas do not require to generate Python or C++ code. And that's why ChatGPT is correct as well.
Hmm. By the way, Edmar connected with me.
Who?
Edmar, the guy who runs the streams on
Streams?
NVIDIA Omniverse.
Oh wow, nice.
Yeah.
What did it say?
He messaged me on Discord, actually.
Oh, regarding?
I was asking, like I said, like I was asking questions on OpenUSD, right?
Hmm.
So he's like, "Hi, are we connected on LinkedIn yet?"
Oh, nice.
Yeah. I wish he hires me as a developer relations marketing engineer, DRM
Oh
engineer
God.
for
He
400K.
might be listening to you right now.
No, bro, zero viewers.
Okay.
Okay. The doc says USD Gen schema supports namespace properties and gives the example that float foobar generates USD. Okay, whatever, codeless schema. So by default, the USD Gen schema generates C++. Okay, it's
Hmm.
saying USD Gen schema generates C++, bro. It is saying, it's not
Yeah, I
saying
know.
codeless.
I know. I know. I know.
Generates
I
C++
know. That's why.
Python providing appropriate APIs. And then clients also have an option of not generating any code by setting skip code generation metadata to true for a given schema, hence generating only generated schema.usda and pluginfo.json, which are the only essential products for runtime schema registration. Since codeless schemas do not provide any code, clients do not need to recompile USD to use or update these schemas. This dynamic nature of codeless schemas is the primary motivation behind using codeless schemas. Okay. So you do not need to recompile USD to use or update these schemas. This is dynamic nature of codeless schemas. Okay. Also, for the same reason, clients will have to use basic USD level API to query prims and attribute associated with codeless schemas. This also means codeless schemas concepts cannot be used for any schema which requires custom code. Oh, bro, this is important. This can be asked as a question. Okay, let's look at what ChatGPT is saying. A codeless schema registers schema definitions without generating C++ Python classes. Over the USD still gets generated schema.usd and pluginfo.json, but will not generate the not full generated C++ and Python APIs. The fuck? Okay, the doc says codeless schema generate only generated schema.usd and pluginfo.json, which are essential products of for runtime schema registration. They avoid recompiling USD but require clients to use basic USD APIs to query prims and attributes. Simple distinction: generated schema, yes. Has generated API. Codeless schema, no. Needs recompilation, yes. Less. Strong typed APIs, dynamic plugin distributed definitions. Bro, this is what this guy DV was showing on that stream.
Mm-hmm.
This guy, I think he showed this part where
Mm-hmm.
he defined his own custom, you
Schema.
know, schemas in like pluginfo.json or something like that. Uh,
Mm-hmm.
so yeah, you see over here he is saying. So this is the codeless one
Mm-hmm.
where skip code generation is equal to true. You see this? This is blur, but
Yeah, yeah,
bool
yeah, yeah,
skip code
yeah.
generation is equal to true. So this is codeless, and here he has defined class creature doc a creature with name, age, and hobby inherits from exformable, inherits exformable string name unknown doc the name of the creature. So this is all default values, and this is all the metadata defining what that is. And then he basically ran it with USD Gen schema, and it becomes like a dynamic plugin distributed definition. I think I
Mm-hmm.
should try it. I should try to do it. Not right now, but
Mm-hmm.
that's a good hands-on, practice to do.
Mm-hmm.
Okay, built-in applied API schemas. hmm Sometimes a typed schema should automatically include an API schema. Example concept: every robot join should always have robot mass API in schema definition form. A class robot joint. What? Sometimes a typed schema should automatically include an API schema. Oh, okay. Every robot joint should always have a robot mass API in schema definition form. Yeah, prepend. Oh, okay. And any robot joint prim gets a robot. Okay, so whatever schema we are defining, we should ship it with an already attached API schema so that it has like custom properties right out of the box. So any robot joint prim gets robot mass API as built-in applied schema. Okay. Customizing per class properties. Okay, here's a short description for each datum. Class name, file name, extra includes extra plugin for schema tokens, X, API schema type, property namespace prefix, API schema auto apply. API schema can only apply to must only be specified on single and multiple apply API schemas. This is token array value that when specified is used by USD prim can apply API and the schema generated can apply function to hand customizing per property. Why the fuck is this? Why is it so pan? Fuck me, bro. Okay. Customizing per. Why is it not covering example schema
Covering.
classes? Why is it not covering the customizing per property part over here? Why is it
I
later?
think it might be covering it down.
Oh yeah, per property customization. Yes. Okay. Bro, this is very big, bro. I think we're gonna take a lot of more time to do this. So do you want to
Hmm.
continue it tomorrow or do you want to keep going?
Like how big is it?
It's very long. Like
Sure.
we have this much to go. We are over here.
Okay. Yeah, then we can
No,
stop it like till until customizing per property then.
we are already at that.
So yeah, like we should not go ahead from over here then because it's gonna be like way big, right? You're saying.
Built-in, yeah, we are at built-in applied API schemas. We are doing this right now. So
Okay,
this
yeah, yeah.
is
Let's
property
do
over
that.
here somewhere. Yeah, I don't know. Okay, I'll end it. When do